So we're going to put 2 in here. Now if you put a 2 in here, that will give you 2 magnesium. So we're going to put 2 in front of magnesium. Is it balanced? Okay. So this is the balanced equation there. Now, we have 225 grams of silicon tetrachloride, 101 grams of magnesium. Which one is the limiting? That's the question you have to answer first. Okay. So if you have 225, convert them into moles. You cannot compare masses there. So in this case, 225 grams versus 101 gram, 101 is less, so magnesium is going to be your, no, you can't do that. Okay, and each mole of silicon tetrachloride is equivalent to 169 grams. Omit all those decimal points there. And when you do calculations there, you have to punch them in there. I'm just trying to show you how to set the equation there. So 225 grams of silicon tetrachloride in this case is being converted into moles there. Okay, and if you do your calculation correctly, you get 1.3243 moles. And you do the same thing for the magnesium. So you have 101 grams of magnesium. Each mole of magnesium is 24 grams. So gram and gram cancels out, okay? And that will give you a 4.1555 mole. Now, if you look at the balanced chemical reaction equation, each mole of silicon tetrachloride requires 2 moles of magnesium. If you have 1.32 mole of silicon tetrachloride, 2 times that number, 2.64. We have way more than what we need. So magnesium metal is in excess. Who's the limiting reactant? Silicon tetrachloride. So silicon tetrachloride is the limiting reactant. Each mole of silicon tetrachloride will give you 1 mole of silicon. So how many moles of silicon can you get? Well, the same number, 1-to-1 ratio. So you will end up with 1.32 mole of silicon. 1.32 mole. Each mole is equivalent to 28 grams. Convert it back into grams, and you will get 37 grams of silicon. Round it to 3 sig-fig. Everything. The measured quantity in this equation has 3 sig-fig, so the answer 37.2 grams. Okay, so this is the type of calculation that you will see in your homework assignment, in the next quiz, as well as in the upcoming exam. We're talking about the exam is scheduled for this Thursday. I think it's a little bit tight, so I will probably push the exam date to next Tuesday so that you have at least a weekend. Well, weekend is my term, and 3 more working days to digest and process the information that we cover in Chapter 4 and Chapter 5. Yeah. And I don't want to, we will probably be able to finish Chapter 5 by Wednesday. This is a fairly big chapter. There are a lot of calculations involved in there. I want you to have a little bit more time to process the information. So on the syllabus and on Canvas as well, you see the exam date is this coming Thursday. We will push it back to next Tuesday. Okay. I don't want to hold exams on Mondays and Wednesdays there, because the Mondays and Wednesdays are the days that I have the option of keeping you here to 12:30 from 8 o'clock. And I will do whatever I can in terms of finishing the topics that we need to cover in the lecture there. And Tuesday and Thursday we have labs, so I can't go beyond 9 o'clock or 9:30, and that's the perfect day for the exam there. You come in on Tuesday and you come in on Thursday and you take the exam. When you finish the exam, you go to the lab there. Okay. So this type of calculation is something that you will see in your homework assignment in Chapter 4. Now, several of you actually emailed me questions about how to do calculations in Chapter 4. Some of them involve limiting reactants. Since we haven't talked about limiting reactant there, my reply is there, so hold on to it, wait until Monday when we finish talking about the limiting reactant, and you do those questions there. In the booklet, the learning objective there, I think it's on page 6 of Chapter 4 learning objective there. There are several questions in there. One of the questions says you start with 50 grams of each. hydrogen chloride, I forgot the other reactants there. Lithium metal hydrogen chloride. When we ask you how many grams of lithium hydroxide, lithium chloride can you get for lithium hydroxide? I can't remember exactly which one is which. But the question there is that when you have 50 grams of each, equal quantity in grams, well, you have to convert those grams into moles. With the moles in hand, then you need to take a look at the balanced chemical reaction equation. Okay, so that's a limiting reactant question that you need to go through there. Okay, so these are the things that you will need to be able to do calculation. In summary, how do we find limiting reactant? How do we do this kind of calculation? The first thing, write the balanced chemical reaction equation. Okay. You need to be able to find the number of moles of each reactant and determine the molar ratio, compare the available moles of each reactant to the moles required in the balanced chemical reaction equation, and then determine the limiting reactant. Okay? These are the general steps. You may not need to go through every single step here listed. However, whenever you're given a question there, and this is something that most likely something that you will need to do one time or another. Okay? So that's a summary of the limiting reactant there. Okay? So what we have introduced here is that when we try to quantify the chemical reactions there, we need to take into consideration what's in the balanced chemical reaction equation. From there, you need to determine which one is going to run out first. That's always going to be a question that you need to keep in mind when you do questions like this. Unless you see the word access, just like the chemical reaction equation, unless you see the word in the question balanced, always check, make sure the equation is balanced. Okay. When you take exams there, if I give you an unbalanced equation, you will see the word unbalanced, so that the first thing you're going to do is to balance the equation first. Okay. And if we do have something in access, you will see the word access. If you don't see the word access, going through these steps, you need to figure out which one is in access, which one is going to run out first. Okay, so that's our, now we went through this particular topic only by doing 2 calculations. Well, we did some other examples, like some more in chicken coop and all that. Okay, so you may think your chemistry professor is just a chemistry nerd. Well, he's actually quite handy. He can also do things. But in addition to that, I also need you to be able to run calculations in this, like this. And you need to be able to solve problems based on the quantities of chemicals given. Okay. The next topic, though, we're moving very fast and don't really give you a lot of time to process this information there. The next topic, we are going to introduce one more conversion factor, concentration involved in aqueous solution. We call it molarity. Okay. So first of all, you need to know how we define molarity. And when you talk about the concentration there, every time you pick up, it just doesn't feel right to say it like this. And when you look at the bottle on of a beer there, and you see 11% alcohol content, we're talking about concentration. I'm not promoting anything there, okay? And we're just using that as an example. We're talking about concentration. Anytime you have a liquid mixed in there, liquid mixture there, you always want to figure out how much of the chemical is dissolved in there. Now in chemistry we have percent concentration, 11% alcohol, that's percentage. Okay. We have molarity, we have molality, we have normality, we have many different types of ppm, and some of them you probably some of the terms